Hello everyone. In today's session, I will be covering the SmartDebug Live Probe capabilities, and then I will walk you through a quick demo. Using LiveProbe, you can reroute signals from any logic element to two dedicated pins that are I/O pads on the FPGA board and continuously monitor signal transitions using either oscilloscope or external logic analyzer. So we call this feature as LiveProbe, and it is primarily used to probe dynamic signals. You can change the probe signals on the fly without recompiling the design or reprogramming the FPGA. This is a major advantage and can save a significant amount of debug time. If you have any doubts about a signal or memory, you can loop the known signals from channel A and channel B back into the FPGA fabric to write a known data to the register or the memory. This can help identify potential issues in the design. However, if you would like to use loopback option, you need to use LiveProbe A and LiveProbe B macros in the design and reprogram the FPGA with updated bit file before debugging. The PolarFire, SmartFusion 2 and Igloo 2 FPGAs contains two dedicated probe points. However, the RTG4 FPGA contains only one dedicated probe points on the FPGA I/O pin. Here is the LiveProbe GUI. Using this user interface, you can assign or change any internal signals to channel A and channel B on the fly. If you encounter a hardware issue, the first step is to check the clock frequency running on the hardware. The user clock frequency option in LiveProbe will help you determine the hardware clock frequency. If you want to observe the number of events occurred on a signal for a time, use the event counter feature in LiveProbe. To measure the frequency of a signal, use the frequency monitor feature. The event counter and frequency monitor features only consider the signal assigned to channel A. Let us now switch to a live demonstration on LiveProbe capabilities. First, I will open the Libero SoC Design Suite software. In this project, I have built a design that includes several key components. The reset logic to manage system initialization, the PolarFire initialization monitor configurator for configuring the FPGA's startup behavior, clock conditioning circuit to generate stable clock signals, and two debug modules, the Fabric Debug and XCVR Debug. In the Fabric Debug module, I am using a counter logic to generate a counter data, which is then fed into three memory components: a dual port SRAM, a micro SRAM, and MUPROM. With the design complete, I have programmed it onto the PolarFire evaluation kit. Let's shift to debugging. In the Libero SoC design flow, under the debug design session, you will find the SmartDebug design. Double click on it. From here, I will select Debug FPGA Array option. In the FPGA Array Debug Data session, the first tab is LiveProbe. Let us monitor the internal signals in real time. On the top left, there is a hierarchical view of the design, and you can also view the netlist view. In hierarchical view, I will open a counter design and add them to a LiveProbe user interface. Next, I will assign one counter signal to channel A and another counter signal to channel B. These channels are linked to two dedicated pins on the FPGA. By connecting these pins to an external oscilloscope, we can continuously monitor the behavior of these dynamic signals. This setup is great for verifying that our counter is working as expected. You can also unassign any of the signal from channel B or channel A and assign a new signal to channels. This flexibility speeds up the debugging significantly. At the bottom left of LiveProbe interface, we have three powerful tools: the event counter, frequency monitor, and user clock frequency. Let's explore each one. User clock frequency. This feature provides an approximate reading of the clock frequency running on the PolarFire evaluation kit. It is a quick way to confirm our clock is operating at a correct speed. Let's visit to the event counter feature. The event counter lets us track the number of events like rising or falling edges for the signal assigned to channel A. Right now in our design, we assigned count A of 7 to channel A. I will click on active event counter option. Let it run for a moment and check the total events recorded. This is an ideal for analyzing the signal activity over time. Let's go to the frequency monitor feature. The frequency monitor measures the toggling rate or frequency of a signal assigned to channel A. You can select the monitor time from 0.1 to 10 seconds. Click on active frequency monitor and see the real time frequency of a signal. This is perfect for periodic signals we want to characterize. That's all I have on our demo. Let me go back to slides. Here are the available resources. The SmartDebug user guide is available on the Libero SoC Design Suite product page. We also have dedicated reference design on SmartDebug, which is available on PolarFire product page. Recently, we conducted a webinar on SmartDebug, and the recording is available on our on-demand platform. I have included the reference links to the product pages and the on-demand platform on our slides for your convenience. Thank you for watching this video.